In this work, we shift from the traditional batch process approach to a more active process of panorama creation, and introduce novel techniques to enable a truly interactive end-to-end panorama creation experience. Current techniques fall short of our desired user experience, for which acquisition should be considered an online process, preview should be instantly available for all stages of the pipeline, and interaction should be maintained without any assumptions on the structure of the data or specialized hardware. To enable this experience, we provide new contributions in registration previews, streaming boundary calculations, and a new robust mesh representation for panoramas. Straight global registration is not conducive to interactive editing or online acquisition. Therefore, we introduce a fast and scalable registration preview which operates on the individual images directly, to allow a user or camera to quickly add or remove images from the panorama. This preview is refined with a background global, unconstrained optimization. The shift from preview to full optimization is slight, therefore edits can be maintained. This technique avoids the pitfalls of previous works, which assume constraints on structure like image order, use of excessive external data like video streams from the acquisition, or need of specialized hardware like gyroscopes or accelerometers. Our preview allows users to fully explore the possible panorama compositions for a collection of images. Here the user explores two distinct, nicely composed panoramas from a single acquisition session. Image boundary calculations can be a significant bottleneck and break interactivity. Therefore, their solutions must be streamed. In this work, we detail how to stream, provide meaningful previews, and reuse computation and local edits for panorama weaving. These approaches are also useful to dynamically maintain edits as data is manipulated. Finally, work on encoding the image and boundary relations in panoramas has assumptions about the structure of the data and therefore has too many failure cases for our target, unconstrained user experience. In this work, we introduce the general fragment mesh which handles dynamic and arbitrary image arrangements. We test our new active panorama editing with a prototype interactive application. This application allows editing and previews of the entire pipeline in a single seamless experience. Due to our new contributions being fast, light, and general, without any need for specialized hardware, they allow for fully unconstrained in-the-field capture and edit sessions. A small laptop computer provides the processing power, while the user controls the prototype software via a tablet device. Since we only rely on a stream of individual images, a camera can be tethered to the laptop via USB, or a user can go cordless with a wireless SD card. Using the tablet, a user can preview the panorama for mistakes, edit, or reacquire images on the spot. In this way, they can guarantee the creation of a quality image. Considering acquisition as an integrated part of the creation workflow is especially useful if additional capture sessions are difficult or impossible. A common use case is for areas of missing data in a panorama, where a user can fill in the gaps by just acquiring a new image. A user can easily use simple registration interaction to reevaluate the feature points for an automatic optimization. This allows the user to shift registration error to a different location in the panorama. Interactive seam editing could help hide this error, with previews provided instantly. Our active pipeline allows for the integration of third-party advanced image processing techniques. Rather than trading error, some registration issues can be fixed by content-aware resizing. Here we use seam carving to fix the registration problem by the pole while maintaining a good registration of the building. And here it fixes the rope misalignment while maintaining the nice registration of the mountain. After the edit, the preview is refreshed and our streaming seam calculation only computes the local seams that are affected by the edit. A user can also be given control to adjust and constrain the full registration optimization interactively. Here is a hopeless case for registration since there is little correspondence between the second and last row. Seams can hide some error, but the distortion of the bench leads to an unrealistic panorama. By actively including users in the pipeline, they can deform the problem images and manually align an object the automatic registration routine may have not considered a feature, say the rock on the right. The user can lock the correspondence between the two images with the rock and rerun the global optimization, leading to a better panorama. Previews are instantly provided to help guide this process. By discarding traditional batch thinking, in this work we provide new techniques to give users a powerful, seamless panorama creation experience.